Fine. So let's discuss from basic definition to next level. Snowflake is a cloud data warehouse which is built on top of 3 cloud products. So why this Snowflake is a cloud data warehouse? What is the meaning of this cloud data warehouse? So I will tell you one by one what is the meaning of cloud data warehouse, what is a data warehouse, what is cloud data warehouse. So what is the meaning of this cloud data warehouse? As Snowflake is a cloud data warehouse, we no need to make any configurations or any maintain any physical servers. As this is a cloud service, just we need to browse the internet and then log in into the Snowflake cloud data warehouse. We no need to, unlike a traditional data warehouses, we no need to maintain any physical components to maintain the cloud data warehouse. Just we need to use internet and then log in into the Snowflake environment, so that we can call it as a cloud data warehouse. And also it is built on top of 3 cloud products. Either it has been built on Azure, AWS, or on top of GCP. And also this Snowflake cloud database can be used for our multiple business requirements. So based on our requirement, we can able to use with the different purpose in a multi-dimensional ways. Like suppose if one organization can be used this Snowflake cloud data warehouse for the reporting purpose. Another project can be used as a business for the business intelligence. Another can be used for application development. Another can be used for data science. Another can be used for the data analyst. So based on the requirement in our organization, so we can use this Snowflake cloud data warehouse. In this Snowflake cloud data warehouse, we can able to load the data from the different sources, like from the RDBMS, like from the cloud technologies, like from the different files. And we can load the data into Snowflake and then store the data into Snowflake. So comparing to the other traditional data warehouses, we have a very good features, and then we have a very performance improvement in the Snowflake cloud data warehouse. What are the very good features? Why we have a performance improvement in the Snowflake cloud data warehouse? We will be one by one. We will see one by one. Before going to see all those features and then improvements, we can discuss what is the difference between the traditional data warehouse and the Snowflake cloud data warehouse. See, suppose let's take an example of SQL Server as an on-prem data warehouse. To maintain our business data into the SQL Server data warehouse, what we need to do? We need to consider multiple things. Before going to build a SQL Server software into a physical servers. Very first, we need to calculate. So, what is the data value we are going to process into the SQL Server data warehouse? And then daily, how many users are connecting to SQL Server? How many IO requests are submitting to SQL Server, and then how many transactions are happening to SQL Server daily. So based on that, we need to configure or we need to build a SQL server into physical server. Based on that, so we need to set up a storage component. Based on that, we need to buy and build hardware resources and data centers. And to maintain all these things, we should be having a multiple database administrators and then multiple network engineers. One second. See here, just I am giving an example as a traditional data warehouse, SQL server. To maintain our entire SQL server data warehouse, we require a database administrators, and also we require a network engineers. We need to build our storage component based on our requirement. We need to set up a hardware resource also. This is suppose once we made all this setup and then start working with the SQL Server data warehouse. Once we started to process the data into the SQL Server data warehouse, if the existing storage component and existing hardware component is not sufficient for the data load, or the existing component is becoming a full, nothing but a whatever we are going to suppose we have made a setup like to store around 100 TB of data. Now tomorrow I am going to load again 10 TB of data. This 100 TB of drive is full. So in that scenario, our batch jobs, our process, our everything will be stopped. So in that scenario, we need a human involvement and then monitor the jobs and then monitor all your activities like SQL Server storage component and then hardware devices, everything we need to monitor and then upgrade it to the next level to process the further data. So in our traditional database, we have so many challenges, guys. So many challenges, and also many human involvement is required, and then many things are need to be upgraded in between the. Suppose if we get the latest software from the SQL Server, we need to update those patches to the SQL Server. If existing hardware resources are not sufficient, we need to upgrade those hardware resources according to the requirement. Existing storage component, and wherever we have mapped that storage component, that drive is full, then again we need to extend the storage component, or where the storage component is host, that drive should be expanded to the next size. So we have so many challenges, and then so many things need to be monitored, so many things need to be managed, and so many things need to be considered. So to overcome that, to overcome all these things, everything is automated in Snowflake Cloud Data Warehouse. Everything is automated in Snowflake Cloud Data Warehouse. Unlike this in traditional data warehouse like hard disk or storage hardware component, in Snowflake we no need to maintain from our end or from our organization, from your organization. The storage component or hardware devices, whatever, Snowflake itself will take care. You don't need to manage anything. So based on, guys, how is done in detail, we will discuss after the session. So based on requirement, automatically the storage capacity or hardware resources are going to expand based on the requirement. We don't need to take care of all these things. We don't need to increase all these things. So based on the requirement, automatically they will expand. Suppose if we have started to process load the data into the Snowflake, irrespective of the size, irrespective of the number of users, irrespective of the IO requests, whatever you are going to load the data into the Snowflake, so based on the data value, based on the IO request, based on the your request, automatically it will calculate internally, and then it will expand and it will provide the sufficient capacity or sufficient storage space to store your data. Suppose we have stored till today 100 TB of data in Snowflake Cloud Data Warehouse. Tomorrow also we are processing around 10 TB of data. There is no space constraint in, there is no hardware resources constraint in Snowflake, because automatically whatever we are going to load the data into the Snowflake Cloud Data Warehouse, internally it will calculate and it will expand its storage capacity to support that storage capacity, or to process the data, or to process that IO request. Automatically the hardware resources are expanding based on the requirement. Unlike in traditional data warehouse, human intervention is not required here. So based on our request, based on our data process, automatically the components will be, automatically the capacity will be expanded. And also in Snowflake, the both storage component and then hardware component, both they are working separately. There is no dependency between the one component to another component. This process has decoupled or separated in a Snowflake environment. And also why we are able to see the very good performance improvement in the Snowflake means, when we load the data and store the data into the Snowflake, data will be stored in a micro partitions and also in column format, and data will be stored in compressed format. So this, how this metadata will be work, how this columnar format, how this compressed format will be work. These things and all we will discuss as part of our regular session. So this is about the high level difference between traditional data warehouse and our cloud data warehouse. As I mentioned, the Snowflake cloud data warehouse has built on top of three cloud products. One is AWS, another one is Azure, another one is GCP. See, why the Snowflake has built on top of these three cloud products. I will give you one example. Suppose let's consider, guys, we are migrating a on-prem server data into the Snowflake cloud data warehouse. Suppose I need to migrate from the SQL Server into Snowflake cloud data warehouse. When I have a data into the objects, I need to load that data into the Snowflake data warehouse, and I need to convert the SQL Server stored process into Snowflake stored process. So in that case, we will get the data from the SQL Server into a files, and the file will be loaded into the AWS, any cloud, AWS or Azure or GCP. I am taking the example as a AWS because I am working with AWS and the Snowflake. Whatever we have a data in SQL Server, that will be uploaded into the files, and those files will be uploaded into a AWS, and then from the AWS we can load the data into the Snowflake environment. We need to make a connection between the AWS environment, and then we need to make a connection between the Snowflake. Whenever we upload the data into the AWS or files into AWS, we can load that data into we can load that data into a Snowflake. And once we load the data into the Snowflake, again, whatever we have a, suppose see here, this is a SQL server. This is a SQL server traditional data warehouse. We want to migrate a data and then code into the Snowflake environment. We can load the files into AWS environment, and then we can load the data into the Snowflake environment. Or else, we have a code. Suppose we have a stored procedure, we have a views, we have a functions. Once we load the data from a SQL server to Snowflake, and then we need to work on the code. Whatever we have stored process, functions, views, we need to migrate that code into the Snowflake environment, which is compatibility with the Snowflake environment. There is a lot of changes between the SQL Server code and the Snowflake code. So we need to get the code from the SQL Server and then convert it to the Snowflake environment style of the code. So this is about the why we are going to use, why the Snowflake has built on top of these three cloud products. And also next, as part of the discussion, Snowflake cloud data warehouse can be called as a software as a service, SaaS, because as we are not going to maintain, as we are not see here, there is no hardware to install, configure or manage the servers. There is virtually no software to install, configure or manage. Ongoing maintenance, management, upgrades and tuning are handled by Snowflake, so that we can call as a software as a service. As I mentioned, we no need to maintain, no need to install, no need to configure anything in a Snowflake cloud data warehouse. Entire thing handled by Snowflake. We no need to buy hardware components. We no need to buy storage components. We no need to upgrade software patches or software updates. Nothing. From your organization, just we need to take a subscription. We need to take a subscription from the Snowflake and then start use Snowflake in your organization based on your requirement. So this is the definition of Snowflake, and then what is the difference between the traditional data warehouse and then cloud data warehouse. We'll see next. So what are the great features are available in the Snowflake? We'll discuss one by one. So great performance and scalability. As I mentioned, data is going to store in a micro partitions in Snowflake in a column format and also in compressed rate. By doing this, we can able to see the robust performance improvement in the Snowflake cloud data warehouse. We will see as part of the course. So what is the micro partitions? How the data is going to micro partitions? How Snowflake is maintaining those micro partitions? How we are benefiting by storing a data into the micro partitions? Everything as part of the class, we are going to discuss all these things. What is the meaning of the scalability? Scalability is one of the very good features in Snowflake. Suppose let's consider, guys, I am using continuously 8 hours, and then after completion of my working day, I am log off my system and then I am not using continuously the Snowflake environment. Whenever you are not using continuously around 10 to 20 minutes, automatically the Snowflake environment will go into the suspension mode. Whenever the environment is go into the suspension mode, the Snowflake will stop you to charge on your organization, and you are saving a cost to your organization. Suppose if you are using only working days, you are not using Saturdays and then Sunday, then the snowflake, whenever the snowflake environment will go into the suspension mode, by that time, from that time onwards, the snowflake will stop you to charge. Again, whenever you are restarting your session, then it will be active mode, and then from that time onwards, the charge will be started to charge on your organization. The beauty is, if you are using only 2 hours per day, then you are going to pay only for the 2 hours. If you are using 8 hours, you are going to use. You are going to pay only for 8 hours. If you are using only Monday to Friday, then you are going to pay only for the Monday to Friday. How this pricing will be calculated? Those things and all we will see as part of the course, as part of the sessions. Next, zero management. I mentioned there are no many things are involved here to manage your snowflake environment. Convenient pricing. Whatever we are going to use the snowflake environment, we are going to pay for that only. Whatever we are going to use, for that only we are going to pay. Virtual compute warehouse. Virtual compute warehouse is the hardware resource. The beauty in the snowflake is, suppose we have around 10 projects in our organization. 10 projects are using the same snowflake environment and processing a data in same snowflake environment. Unlike a traditional data warehouse, based on the projects, they can able to create their own virtual compute warehouse. This virtual compute warehouse is the hardware resource to your snowflake environment. So based on the projects, they can able to create their individual virtual compute warehouse, and they can use their individual virtual compute warehouse. Suppose I have a project, multiple projects in my organization. Project 1 is creating their own virtual compute warehouse. Project 2 is creating their virtual compute warehouse. As project 1 is created their own virtual warehouse, as project 2 is created their own, so they will not be using a different virtual warehouses. Project specific, there will be a separate virtual warehouses, so that we can able to see the benefit and we can able to see the good performance in the process, because they have created their own individual virtual warehouses. There is no dependency between the one virtual warehouse into the another virtual warehouse. Project specific, we have created a individual virtual warehouse so that we can able to see the lot of improvement in the snowflake environment. We will, guys, whatever we have a queries, I will give you enough time after this session. We will discuss. Let's focus on the discussion. Next, what is this unwrap statement? Recover snowflake object using unwrap statement. Fine. Suppose, let's consider, guys, if any table or any schema or any database is deleted from the database, from Snowflake data warehouse, instead of doing a multiple steps like going into the backup devices, identifying the latest backup, and then restore from that backup devices, just by using a unwrap statement. Suppose, see here, one second. See, so this is the database. In our traditional database, what we will do? Suppose any table or any schema, any database is deleted Suppose in SQL Server we have multiple databases. If any database is deleted or if any tables are deleted from this table, what we will do in our traditional data warehouse? We will go into the multiple backups which are taken and identify which is the latest backup device, and then from that latest backup device we are going to restore that backup into our database. If we want to restore a particular database or else schema or else table, we need to go into the multiple backup devices and then identify the latest backup file, and then we need to restore that into the database. Suppose if you lost any database or else table or else schema in our traditional approach. In case of Snowflake, we no need to do anything. Just by using a unwrap statement, we can able to restore those deleted objects into the Snowflake environment. So this is one of the very good feature. Just using a unwrap statement, you can able to restore the objects in the Snowflake environment. Next, what is this object cloning? Suppose let's consider, guys, we need to work in a different environments, and first initially we need to develop our objects. Suppose we have a development environment, QA environment, and then production environment. Directly, as we are not working on the production environment, we need a production copy of the data into our development environment and work and develop your things in development environment and then move that code into the production environment. So here, to work in the development environment, we need a production copy, production data or production copy of the data. To do that in our traditional database, again we will get the backup from the production database and then restore into the develop. Suppose this is just I'm giving example. Consider this is the production environment, this is a development environment. Again, we need to take a backup of this database and then restore into your development environment. Here, multiple jobs are involved. This is not that much of easy. We need to make a multiple steps here. So you need to run the jobs, you need to take a backup, and then you need to restore that backup. You have multiple steps are involved, not that much of straight away here. So to overcome all these things in Snowflake, what we have a very good option is just using a cloning word. Cloning, you can able to just using a SQL statement by use with the cloning word cloning, you can able to copy the backup, the database into the lower environment. Just you can using the clone, you can able to create a duplicate copy of the database and then you can restore wherever you want. So that is a very good feature is here. Undrop, this cloning, and also you have time travel here. This is also one of the great features in Snowflake. This semi-structured data is rather than a regular data processing, we can able to process semi-structured data also, like JSON and then XML data. What is this time travel concept? Suppose let's consider, guys, you have a customer table. In customer table, we have around 1,000 records, out of which 10 records are modified. So once you validate the data, so we identified and we came to know that whatever we have done the modification, that is wrong. We need to restore that original 10 records into that customer table. So in that scenario, what we are going to do in Snowflake, the Snowflake will maintain the history of the table for the particular days. As Snowflake is maintaining a by default if you provide a particular number of days to maintain the history to the table, the Snowflake will maintain the history of the table for the particular days. Within those days, you can able to go back into the history of the table, and whatever the modified records you need to restore into the original table, you can able to bring back those records using a time travel concept and then restore those 10 records into the table. So these features will not available any other data warehouses. So these things are available in our Snowflake Cloud Data Warehouse only. This is very easy. If the data is deleted from the table, if you want to restore the data using time travel concept, you can able to implement that. This is very good option actually. Using a simple way, you can able to restore that data. So that is a beautiful concept here. So next, using a streams and then tasks. So this is to load the incremental data and then to schedule the SQL objects here. And the data sharing and the snowpipe. Data sharing is the one of the very good feature we will see as part of the course. This snowpipe is the one of the object in Snowflake. You are automating everything. When the files are landed into the your any cloud technologies, and then you need to load the data into the target tables in the Snowflake, you are automating the process, entire process by using the Snowflake objects. So these are the just high level discussion on the what are the good features are available in the Snowflake. And as part of the course, as part of the regular sessions, we are going to discuss, we are going to create, we are going to use all these components and the concepts very in detail. So this is our Snowflake data warehouse development course content. So whatever I have mentioned, all the topics, so we are going to discuss very in detail, and then we are going to create all the objects and we will explore everything. So I am going to targeting this course to complete by 35 classes. Prerequisite for this course is, if you have a SQL knowledge, it will be added advantage. If you don't have a SQL knowledge, as part of the course, we are going to provide the knowledge on the SQL. Whatever we are going to discuss as part of the session for the particular day, once the session is going to complete, I am going to share the theoretical notes, and also whatever we are going to create or whatever we are going to execute, whatever we are going to discuss, the code, everything, I am going to share every day end of the each session, so that you can practice from your end and so that you can study from your end. Apart from this course content, we will also help you guys to prepare the interviews, to prepare the resume, and also if required, we will explain the project requirements also, and also real-time environment experience also we are going to discuss with you. Next. So how is the career opportunities on the Snowflake? How is the career opportunities on the Snowflake? Guys, I can mention now, so majority of the projects are moving or migrating from on-prem servers into a Snowflake Cloud Data Warehouse. Hence, market is looking a very good Snowflake developers. Market is looking for the very good Snowflake developers who is having very good commanding on Snowflake technology and then concepts. You will be having the very good opportunity in the market, and also compared to other technologies, now you have a good opportunity to get the very good package on the Snowflake technology. Suppose in total, if you have a 7 to 8 years of experience, out of which you have a 2 to 3 years of experience in your Snowflake, you have a chance to get the package between the 25 lakhs to 30 lakhs. Because many of my juniors and many of my colleagues, got the same kind of packages in Snowflake technology. So what are the certifications are available on the Snowflake? So we have a Snowflow certification. This is the first one, and remaining under advanced certifications. To attempt to do the advanced certifications, we need to have a experience and we need to know the internals of the Snowflake environment. What are the rules and responsibilities once we get the job on the Snowflake developer? As I mentioned, majority of the organizations are working on the migration projects. We will be working on the migration project. Either you will be working on the data migration, either you will be working on the code migration. So, as part of the requirement, we are going to work on the migration things. So, what are the opportunities we have? What are the kind of jobs we have in the market on the Snowflake? So, you can apply as a Snowflake developer and the cloud data engineer, Snowflake data engineer, data analyst, data scientist, cloud data warehouse engineer, Snowflake data engineer, Snowflake developer. So once you comfortable on all these Snowflake concepts, whatever we are going to discuss in as part of our course, once you are very good at the Snowflake technology, then you can able to apply on all these jobs. So this is about today's discussion, high level discussion. What is the Snowflake and what is the cloud data warehouse? What is the difference between the traditional data warehouse and then cloud data warehouse, etc. Now, if you have any general questions, then you can ask me, guys. If you have any questions, you can ask me now.
So, Shekhar, I had two questions. You mentioned about the ETL process from SQL Server to Snowflake. Are we going to talk about it in detail down the road? And the other question you mentioned was that there are several different warehouses present in the Snowflake. So, what do you think is the right approach to decide or design that how many warehouses one organization should have? Thank you.
So you mean to say virtual compute warehouses?
You mentioned that an organization has multiple warehouses in Snowflake to do different operations like the data load or query.
One second. Let me rectify that actually. Let me rectify that. You mean to say while discussing this virtual compute warehouse, right?
Yes, correct.
Yeah. So let me rectify that sentence actually. This virtual compute warehouse is like, one second. Virtual compute warehouse is like hardware. So as we have a hardware resources in a traditional data warehouse, right? Agree? Hardware resources may be CPUs or RAM, etc. So these hardware resources are very much required to process our request, right? Understood?
Right. Yeah.
So same hardware resources are replaced with virtual compute warehouses in Snowflake. One thing. Second thing is, in traditional data warehouse, this existing hardware resources are shared by across the organizations or entire projects or multiple teams, right?
Right.
Hello. I mean to say, once we build a on-prem servers in our organization, irrespective of the projects, irrespective of the teams, if they are using this particular SQL Server data warehouse, For the SQL Server data warehouse, whatever the storage device, whatever the hardware resources are shared across all the projects, all the team, and the entire organization if they are using this on-prem SQL Server. Is it correct or not?
Yeah.
Next, coming to my discussion, as this virtual compute warehouse is a hardware resource in your Snowflake environment, what I mean to say, if our organization is having a 10 projects, 10 projects are using a same Snowflake environment, and then they are processing or they are connecting to Snowflake environment. Instead of sharing a single hardware resource to across the 10 projects, we have an option in Snowflake environment. We can able to create individual virtual compute warehouse for the particular project. If we have a 10 projects in our organization, 10 projects are using a same Snowflake environment, then we can able to create a 10 virtual warehouse, and then we can use their individual independent virtual warehouse. Nothing but the hardware resources are not shareable to all the projects. They are using their own hardware resource. Even though it is the same environment, you can able to create how many teams are using, how many projects are using the environment. They can able to create those number of virtual warehouses, and then they can able to use their own independent virtual warehouse. I think you got your answer. You're clear now.
You are correct. Just one more clarification as a follow-up. So if we have, for example, if we have one project with DurgaSoft and one project with CNN and one project with Google, no, Google is the wrong word. One project with some TV station. So each of these projects will have their own ETL processes, own reporting, on all the transactions. So my question is that you will be creating all of these components, I guess. Hold on, let me rephrase it. So you will be creating a separate warehouse for each of these components on each of these projects. Am I correct, or I'm saying it wrong?
Correct.
Thank you. Oh, good. I got it.
Correct. Other questions, guys? Other questions? Anything? Anything? Whatever you have in your mind.
I had the ETL question earlier that you mentioned that the ETL from a SQL to the Snowflake. Are we going to talk about it down the road during the lectures?
Yeah, we can. Yeah. That's fine.
Okay. Thank you.
Guys, other questions from others?
Yeah, Shekhar. Coming to Snowflake.
May I know your name, please?
Yeah, this is HariBabu.
Yeah, Hari.
Yeah. Coming to Snowflake, we know that the ETL process, like on-premises, the plan that we are doing is the existing code and data that we are going to convert into Snowflake data warehouse, correct?
Correct.
Yeah. And that is for conversion, we are doing like we are pulling the source respect to whatever it may be RDBMS files into respect to some file system mechanism. From there, we are loading into target, that is into Snowflake data warehouse. Okay. Yeah. And coming to scalability, you said that we are like monitoring the data from 24/7, right? Coming to prod environment, as you said, for the scalability, when we are not using the resource like the CPU, whatever it may be, there is a retention period. After 8 hours, like it is automatically getting switched off. Suppose it is like, as you said, it is like applicable to like QA or dev environment. If it is like prod, it is like 24/7. Then how it
Correct.
is going to? We need to use 24/7 consumer, right? The maintenance
See,
will be.
one second, one second. Good question. Now again I need to go back to our traditional data warehouse here. See, just I will give the example and then compare so that I'm coming here and then explain so that you guys will get clarity. Suppose you have a SQL server. Let's consider SQL server production environment. Hurry, fine. If this production environment, your question is, if production is environment is down, then at that scenario, then what we need to do, right? Hello.
No, if it is Shekhar, if it is production environment, then the utilization will be not like switch off like as you said. If it is we are not utilizing the resource.
See, if it is a production environment, if it is QA environment, if it is development environment, this is specific to user level. Suppose this is a production environment, Snowflake production environment. If Hari is connecting to Snowflake production environment and working, so his working hours has done, and then he is logged off the system continuously. This from the Hari session, continuously 10 or 20 minutes, Hari is not going to use this production environment from his end. For the Hari session, it is going to automatically going into a suspension mode. So from there, you are saving some cost to your organization. Fine. Nothing but entire this environment not going into a suspension mode. For the user Hari, it is going to suspend for the particular time. Clear?
Yeah, I understand.
Right. Any other questions, please?
And one more, the SQL. We know that basic like any of the SQL language. Is it fine, or is there any specific SQL language for?
That is fine. If you know any SQL, that's enough.
Then my ask is like, is there any independent like SQL for Snowflake, separate like?
No. If you know any SQL, then that will be fine. Then using the existing knowledge, you can
Okay.
proceed with that.
Yeah, and you said like the theoretical notes for every day, right? What we are discussing, that will be like we need to note, or you are going to give soft copy?
Soft copy only. I will share
Fine.
the notepad.
Yeah. And this is one more like you said like we are doing almost all in Snowflake. We are doing migration only, right? We are not we are not like doing it as a part of a development, right?
Development also will do. Development means what is the meaning? Development, if you have already data loaded into the Snowflake, from there you will develop your code, writing a code and implementing a Snowflake concepts like that. No?
Okay, this is called development. That is, suppose let us take an example. If the data is available already in your Teradata or SQL Server data warehouse, we are converting the data into Snowflake. That what we are doing entire the end-to-end process is called as a development, right?
Migration.
Okay, that role we are giving as a data analyst or like CW engineer.
So based on the organization, they will do the data engineer. Usually they will do data engineer.
Okay, internally the work what we are doing, it will be unique.
Hari, if you have any still multiple questions, we will discuss one by one after the 4 hours.
Yeah. Thank you.
Let others discuss. Guys, any other questions from anyone? So from tomorrow onwards, we are going to start our regular classes at 7 a.m. So we will meet tomorrow at 7 a.m. if you don't have any queries. Is that fine?
Hi, Shekhar.
Okay, yeah.
Yeah, this is Ashok. Okay,
Sure.
so we have a traditional ETL systems, right? Like Informatica and cloud also an Informatica IICS. Okay, so how it is different from traditional ETL system and IICS, this Snowflake, and in the traditional systems also we are modeling, right? We have some modeling the object tables and all by using some modeling techniques. So is the same process is there in Snowflake? So how?
Here is, so you are talking about the first thing is ETL, second thing is data modeling. So
Yeah.
ETL is different. See, we can able to connect the ETL to your Snowflake environment.
Okay.
So if you have a AACS ETL, if you have a data stage, if you have a medallion, then you can able to connect those ETL to your Snowflake environment. That is one thing. Coming to the data modeling, whatever we are going to follow the approach, you may heard about the different schemas like star schema, Snowflake schema. So using those schema, so same thing. So here also applicable while designing a database, while creating a tables.
No, Shekhar, my question is, so IICS is also cloud ETL, right? So Snowflake is also cloud.
No. See. Don't get confused. This is not an ETL tool. Snowflake is not an ETL tool. Suppose, so in which database you are working? You have knowledge. Tell me.
SQL and SQL Server.
SQL Server. Suppose consider SQL Server. SQL Server itself here. You have SQL Server itself here. So you can use as a SQL Server data warehouse or as a SSAS, right? SSAS is the SQL Server data warehouse. Fine. On top of that SQL Server data warehouse, you can, if you want to use SSIS or as a ETL tool, if you want to use SSRS as a reporting tool, like that Snowflake is a one of the data warehouse. On top of it, if you want to connect any ETL tool, you can able to connect. If you want to connect any reporting tool, you can able to connect. Like your SQL Server data warehouse, this is also a one of the data warehouse. You can store the data here. On top of it, you can able to connect the ETL tool.
But if we use
that's correct, Shekhar. Actually, yeah, I am little bit confusing. Just to clarify me. Okay, data warehousing is also we need to model, right, by using some schemas. Okay, through the ETL only we are extracting the data from different source systems and loading into the data warehouse. Okay,
Correct.
you mean to say, so Snowflake is especially designed for to develop the warehouse and load the data?
Correct.
So that means, can we do the data modeling in Snowflake or not?
We can do data modeling so that we are going to create all these tables, right?
Okay. One more thing you mentioned earlier during this discussion, that we can connect the ETL tool to the Snowflake, but when we connect our ETL data pipes to Snowflake, we will have to change them so the database tables are converted into CSV files and then loaded into Snowflake, right?
Correct.
Okay. So that's extra work. Wow.
Ashok, let me explain for your question. If you are not clear, one second.
So I thought that the Snowflake is a ETL tool,
One second,
but you are telling it.
One second. Let me explain.
Okay.
See, in your SQL Server, suppose let's consider this is your SQL Server data warehouse. Fine. This is OLAP system. So this is SQL
Correct.
Server OLTP. This is OLTP system, right?
Yeah.
Right. This is your different sources. Okay, different sources. You will get the data into the SQL Server, and then from there you are going to load the data into your SQL Server data warehouse. Is that fine?
Correct.
And also here to your SQL Server data warehouse, this SQL Server database is one of the source, correct?
Correct.
And also, if you have a data into files, you can able to load directly into SQL Server data warehouse, and this file is also one of the other source, correct?
Correct.
How do you load the data from this file into SQL Server data warehouses? By connecting a any ETL tool.
Correct.
Correct. Now, what is there in the SQL Server data warehouse means the data is stored in a SQL Server data warehouse from the different sources. Correct.
Correct. Correct.
How do you load the data means by connecting a ETL tool.
Correct.
Like that. In Snowflake also. Suppose let's consider in Snowflake also. You can, one second. Suppose this is, let's consider this is a Snowflake environment and then this is your SQL Server environment. Fine. Once you want to load the data from the files into a Snowflake means either you need to place those files in any one cloud technology. As I mentioned here, either AWS, either Azure, either GCP. You can load those files into any one cloud technology and then load the data into that entire data into your Snowflake environment, raw data.
Okay.
Raw data, you can load the data into Snowflake environment. Just focus on my explanation. Once you load the raw data into your Snowflake environment, the same thing I have designed here, one more slide here. So you have a files in your cloud technology and then you are loading raw data into your Snowflake environment. On top of the Snowflake environment, as you have a raw data, if you want to do a ETL operation, if you want to do a ELT operation, you can able to do and then apply some transformations. And then load the data into target table within the Snowflake environment. As you have a raw data in your cloud technology and the same data you have moved into your Snowflake environment. Now, in Snowflake environment, same whatever the files are available in the cloud technology, you can bring those files into a Snowflake. Nothing but you can refer whatever the files are available in the source system. Same files you can refer here by creating one of the object. Nothing but the same like files also you can refer here on top of it within the Snowflake environment. I am telling within the Snowflake environment. If you want to do a ETL operation or if you want to do a ELT operation by using a Snowflake SQL, and then load the data into target table which is available in the Snowflake environment. This is the one approach. What I mean to say, suppose if you have a SQL Server data and then you loaded the data into the files and then you need to load those files into any one cloud technology and then load the data into the Snowflake environment. This is one approach. Second approach, you are comparing with the ETL tool. You have a data and then you need to load the data into the Snowflake environment. Suppose if you want to connect any ETL tool, then you can able to connect it to your SQL and then Snowflake and then load the data into Snowflake environment, either IACC, either data stage, either Medallion, etc. This is the one approach to load the data into the Snowflake environment by using a ETL tool. And then if you have a files in your hand, then you can load those files into your cloud AWS or Azure or GCP. You can load the data into the Snowflake environment, raw data. And then by using a Snowflake concepts, so that is called the development here. Once you load the raw data into your Snowflake, nothing but you are loading the data using ETL tool into your Snowflake environment. While loading a data from the ETL tool, you will apply the many transformations here as the ETL tool. This is one option. So this is second option. You are loading a raw data into Snowflake environment. By using Snowflake concepts, you will do the ETL operations and then load the data into target table. Then we are going to discuss as part of our course this part. We are going to discuss this part. Now, tell me, Ashok, still you have any questions?
I have a question.
From the source SQL server to AWS, we can load the as a raw data. From AWS to Snowflake, we need to load, right?
AWS to Snowflake, we can load, correct?
Okay. From SQL server to AWS raw data, how we will process, Shekhar? Through the Snowflake concept or?
No. We need to load the data into the files.
Okay. Snowflake 5 load and from AWS to, and one more thing, Shekhar. So this same process we can achieve through ADF also, right? Azure Data Factory.
That's what Azure, na? I told you.
Okay,
That's what
above one.
Yeah, see, we can do with the either AWS, either Azure, either GCP. I have given an example with the AWS. You can do with the same thing with the Azure also.
Okay. Yeah, that's what my question. So how it is efficient compared to other ETL clouds or traditional? Why we will go for Snowflake?
Why we will go for Snowflake? Snowflake, I have given you a lot many good features. Na? As part of the session, I have explained many features here. Those features are not available in other data warehouses.
Okay. Yeah. No question, Shekhar. Okay, I have some clarification. Okay.
Fine, guys. Tomorrow we will meet at 7 a.m. If you don't have any other questions, then we can close the session. If you have any questions, then you can discuss.
Shekhar installation and all, you are help me, right? And practicing. If you have we have a doubt in earlier session. Are you clarify? So how can?
Installation is not required here. We need to create a Snowflake account and then start using that. I will make you to create the account from your end.
Okay.
No installation is required. Nothing is required here. Just you need a internet connection. That's it.
I have a question which you told earlier. From suppose like you said, like from AWS to Snowflake data warehouse, we can load the raw data, right?
Correct.
So how we are going to load that raw data using any ETL tool, or how do you load it? I mean, after that you can do the transformations on it. No, not an issue. But how do you load it?
Yeah, that's right. If you have files in your AWS, and then you will make a connection between the Snowflake and then AWS. You will make a connection between the Snowflake and then AWS. Once the connection is established between these two environments, we will create a couple of objects here to get this data into the Snowflake. We will
you just copy those files to Snowflake.
We will do some development part here to bring this data into this area. Clear?
Yeah, thank you.
Fine, guys. We will meet tomorrow at 7 a.m. Is that fine?
Yeah. Thanks, Shekhar.
Yeah. Thank you. Bye bye. Have a nice day.